Okay. Okay. So this is being recorded. So as I go through stuff, the main thing that you want to be aware of is that any questions you may have in the future, or if you want to get information about any Flux service, probably the easiest way is a one-stop shopping for anything to do with high-performance computing is to email hpc-support@umich.edu. I'll put up a slide with that at the end to point that out. So I'm going to cover two different pieces of information. I'm going to go over the different Flux services that are available right now. Not everyone's aware of everything that's available. The other thing is that there is a new set of rates announced. That is, the price for most of the Flux services has fallen, sometimes significantly, and I will cover the different subsidies that the three major schools and colleges kick out. Okay, so Flux. Here we go. Okay, so hopefully everyone can see this webpage. So Flux is the primary high-performance computing platform on campus, depending on who you are, but is the only campus-wide resource. It comes in a couple different flavors. I'm going to go over those, and also it is a fee-for-use service, so you kind of pay for it as you use it. And I'm going to go over some of the ways in the second half of this to make the most of how to get access to a Flux allocation, how you can manipulate them to get the most out of the service, and some of the tricks that people don't realize exist. So there's a couple of different Flux services, and I'm just going to go ahead and type them all out here. So the main Flux service is something we just call like Flux Standard. Flux Standard has a few features. It has every core comes with 4 gigabytes of memory per core, and the nodes either have 12 or 16 cores per node. The thing about that is means that you can actually request more memory per core. So the way this works out is if I have a 4-core allocation, that means I have a total of 16 gigabytes of memory I can allocate. So that means I could submit a 1-core job with 1 gigabyte of memory, and that means I could also submit a 1-core job asking for 10 gigabytes of memory. So the 4 gigs per core, really what that is that's how we build our hardware. And as we recover the cost for the system, we actually let you munge it. So if you buy, 16 cores worth of stuff, that means you have 64 gigs of memory you can allocate among your jobs as you please. So if you have different workloads in your group, realize that what happens is we set a max proc and a max mem. So we combine these together. And so this is going to be true as I talk about the other services too. So as you buy an allocatable unit, which on Flux is 1 core and 4 gigs of memory, you can then pull from those different allocatable units independently. In the case of standard Flux and large memory Flux, you can pull cores and memory independently. So the other thing about standard Flux, it is $11.72 for full cost. And so for COE, Med, and LSA, currently they subsidize it to $6.60 per core month. And so that means 1 core for 1 month is only $6.60 for the majority of users. For those of you who are in colleges unaffiliated, or in programs that are unaffiliated with the 3 large schools there, there's currently no subsidy from places like SPH and other departments. So you do have to cover the full cost. But $11.72 is still significantly less than the old rate. So this is all the new rates I'm quoting here. So this also comes with, this comes with InfiniBand, disk, and software. So this is a fully usable service right here. So this gives you storage, a high-performance network for communication for parallel jobs. We also move data over that network, so everything is connected using InfiniBand. The next service is something we call Flux M, or large memory Flux. This is, here, let me do it this way. This has 25 gigabytes per core, and the nodes have 32 or 40 cores per node. So this works out to a total of 1,020. Really, the way these machines are built is there's 1,024 gigabytes in a single node. So this is the large memory service. The full cost for this is $23.82. And so the COE, Med, and LSA cost for this is $13.30. Let me get a little spacing here so it's a little bit easier to read. So what's this mean here? Because there's two different features you can think about Flux M. Oh, and Flux M shares all the other features of standard Flux. So things like InfiniBand, disk, software, that all comes with a Flux M allocation. So really the way this works out is that if you need to use more than, say, 8 gigabytes per core, this works out to be cheaper, right? Because 2 standard Flux units would give you 2 cores and 8 gigs of memory. So if you needed something that used 8 gigs of memory in 1 core on standard Flux, you'd have to buy 2 cores to get 8 gigs. So that would, run you, if you were subsidized, $12, $12, $13. If you notice on Flux M, 1 core comes with 25 gig and is basically $13. So that's how it works out, that if you need more than 8 gigs of memory per core, Flux M is going to come out to be cheaper. The other feature it's good for is because there's so many cores in a single machine, if you need a large quantity of cores in a single box for shared memory, it may also be a good option for you. And again, they have InfiniBand and all the software and everything of normal Flux. So those are the 2 primary services that are available. Standard Flux, we can get you thousands of cores. Large memory Flux, we can get you hundreds of cores right now. And we may have other options available, so always talk to us. Also, I'm going to check in on the room every now and then. So if there's questions, go ahead and send them to me so I make sure I get those answered. Okay, so there's Flux M. The other thing is something called FOE, or the Flux Operating Environment. This is all of the Flux service minus the physical node. So this is for people who have hardware-only grants. So this would be the case where if you were provided funding where you could only buy nodes, you can add them to Flux, and basically they become a permanent part of Flux that only you can access. It costs more just because there's no oversubscription like there is in standard Flux, and of course then you're committed to those machines for a long time. But basically this is everything Flux has. So this pays for your InfiniBand, this pays for the software, this pays for your shared login environment, this pays for the software. This covers everything except for the physical node. So this works out as $113.25 for the full cost. And for the subsidized schools, they have decided to cost this down to $63.50. Now this is on a whole node cost. So you can't compare this core for core, right? Because you need to know what's going in your node. So a 16-core node on normal Flux is $6.60 times 16. While in this case it's just $63. So you have to realize these costs are a whole node because there's one physical connection. There's no partial nodes in Flux operating environment. So FOE, we don't expect a lot of people to use that right now. That could change in the future, but it is a case of you're kind of locked into that type of thing. So these are the 3 services that are live right now. You can get these literally right now. Any questions about the services that are live before I continue? Yes. Is FOE a per month cost? Yes, that is a per month cost. Everything, because it's a service, has to be done monthly. So yes, you may get a grant only for hardware, but that means then you have to come up with this funding for everything else besides the node going forward. Realize that for Flux we pay for everything: electricity, rack rent. We pay for literally everything. But you get the full service then. If you buy nodes that look just like standard Flux, you're going to get something that acts just like our regular Flux service. That answer your question? So the next thing I want to touch on are services that are coming. So the next service that we are literally extremely close to is Flux with GPUs. And so these, we actually physically have these installed. It is just a process of figuring out exactly how we're going to allocate them, some testing to make sure the software environment works as expected. But we currently have 64 of these. And so this consists of, there is a rate already for this, and so the full cost is $107.10, and the COE Med LSA cost works out to $60. And this is a per GPU plus 2 core. Our systems have 8 GPUs per node and 16 cores, so every GPU comes with 2 cores. So you can allocate those as you please. These are NVIDIA K20X cards, which I believe are the fastest Tesla cards you can get currently. So these are extremely high-powered GPUs. So the way this works out, compare this to standard Flux. If you have a code that can use both the GPUs or standard parallelism, you can figure out what kind of speed up you need to figure out if GPUs are a better cost, like cost per unit science, right? So if the speed up on a GPU here, so standard Flux was a 660, so let's say it's around $6-7. So we would need about a 10x speed up on a GPU to justify using GPUs over CPUs from a pure cost basis. And so a lot of times that's not hard. It's not uncommon for a lot of codes to see 20, 30, 40x speed up. One of the codes I continually check has about a 70x speed up on a GPU versus CPU core pretty much through all generations. So you have to figure this out. So if you're curious in this, please let us know at HPC-support, and you'll be looking for an announcement for when this becomes generally available. So the following services, though, so let me make a I'll just put that down there. Okay, so the next services are something we call technology previews. Flux generally runs one or two technology previews at a time. This is normally something that appears to be an up-and-coming technology. The thing with up-and-coming technology is that we're not exactly sure what we're doing as admins, whether it's really going to be useful. So normally it's something it's a small pool, but it's meant for people to be able to test and start doing work on. And if people consume it and use it, we'll actually turn it into a real service. So the thing about the previews are they are generally free. So the two previews are, the one that's currently available is Hadoop. Hadoop is an implementation of MapReduce. So if you look at data-intensive computing and things like that, we have a Hadoop service. It's currently pretty small, but we have ordered some additional equipment to expand it to increase both its performance as well as its capacity for the amount of data it can hold. And so we're looking for people to try out our Hadoop environment, give us feedback in terms of like how it's managed, whether this service works for them, and whether this is something they would use. So this is something where we're really looking for feedback. So we're looking for people to use it. You can do real science on it. It'll be around for at least a year or two. But we're really looking for feedback to how to improve the service. Okay, so this is available now. And actually, I should make a note that this is greatly expanding soon. The amount of equipment we're adding is very significant to really increase the amount of data the system can hold. The next piece is the next service that's coming is a Xeon Phi, otherwise known as the MIC, or the Many Integrated Core. So this will require a standard Flux allocation to be able to get access to, but there's no additional charge to use the Phi card. So there's 8 of these. The thing with the Phi card is that it acts like it's basically Intel's GPU type card for scientific computing. We have a number of math libraries like the MKL and a few others that have functionality to kind of turn code into using the PHY card. You can also use the Intel compiler to say, hey, I want to transparently offload this onto the PHY. So this is something, when it becomes available, you may want to take your code and compile it with PHY offload and just see how it performs. The PHY itself looks like a mini Linux computer that you can talk to from the host CPU. And so the reason, you still need a standard Flux allocation, it's kind of like the GPUs on Flux right now. The current GPUs on Flux that you can use today are the previous generation and were a tech preview. So you had to have a Flux allocation to get the CPU to host a GPU, but the GPU was free. Well, with the Xeon Phi, it's the same thing. You need to host Flux allocation, which is $6.60 per core per month, and then you can use the Phi and see how that works for you. And again, we're looking for feedback on this. Would this be used if we expanded it? Is it a justifiable cost to actually get more of these and turn them actually into the normal service like we normally would? So those are the services we're looking at doing right now. So Hadoop's available as a tech preview. The GPUs are almost on, the new generation of GPUs turning. And so the current GPUs are shown as an example of a tech preview that was turned into a real service. So we started with 8 previous generation GPUs we didn't charge for. Now we have 64 current generation GPUs that will be charged for, and will be hopefully useful to those of you who have applications that map well to it. So those are different services. So we have standard Flux, which is what most people use. That's the thing where we say we have 10,000 cores on Flux. That's what we have. We have 10,000 standard Flux cores. Large memory Flux, that's the next most popular service. That's the 25. It's like regular Flux, but they're bigger nodes or fat nodes with a lot of memory. So they have 25 gigs of memory per core. Then we have the Flux operating environment that lets you add machines to Flux, where you physically own the machine, but we operate them like a Flux node. Then we have the upcoming services, which is Flux GPU, which is a GPU service that comes with 1 K20X plus 2 CPU cores. Then we have the tech previews. The currently available one is the Hadoop resource, and the next coming one after that, once we get some software stuff figured out, is going to be the Xeon Phi or the Intel mic. They changed the naming. The mic was the engineering name that most people know it as, but the Phi is the marketing name that they actually released it under. Okay, so that's all the services, and I covered the rates on all of those for both the full cost and the subsidized rate. So if you're an engineer or affiliated with engineering, someone in the medical school or affiliated with someone in the medical school, or an LS&A or affiliated with somebody in LS&A, you can get these subsidized rates because those schools have chosen to pay part of the rate, bringing the cost down to you. Okay, so any questions before I continue? Feel free to put something in the chat box. Okay, so that's the services. So the next thing is how do you actually get a Flux account? How do you actually get one of these things? It's actually pretty straightforward. All you do is email hpc-support and tell us what you want. That's all you do. There's no web form, there's no hoops to jump through. You just send us an email and we'll give you the boilerplate. But there's standard sets of information that we will need. We will need a start date. We will need, really a start date and a duration in months. All Flux allocations, which I'll show how an account have more than one allocation, last for whole months. You may have heard something called Flux on Demand. Flux on Demand isn't available yet, and we don't know when it's going to be available. If you want details on that, email us in terms of adding your voice to that discussion. But Flux allocations are for whole months, and it's kind of like reserving a core. It's there for you whether you use it or not. So if you reserve the core for a month, $6.60. If you never ran anything, we still charge you for $6.60. So we need a start date and a duration in months. We need a core count. And the type. This is standard, large memory, GPU, etc. And then we need a list of users. These are the users who can run on this account. So this is who's allowed to actually submit a job on Flux against this set of resources. And then we're going to need a list of admins. The list of admins are people who are allowed to spend money. So this is basically who's allowed to say, please extend this allocation, please cancel it early, change to this short code, add and remove users. This is also the list of people who are going to get an email. So when an allocation is getting ready to expire, we will send out an automated email that says, hey, your account, something_flux, has an allocation that's expiring, and it will have the allocation ID, the number of cores, and when it's going to end, and any other allocations this account may have. Because accounts can have more than one allocation. I'll illustrate that here in a little bit. And so this list of users are the ones who are going to get that email, and this is going to expire, and you can email us saying, please extend it, please modify the number of cores, etc. So this is, and this is also who's allowed to see M reports. mreports.umich.edu is a place where you can get a lot of reporting information on your different projects and stuff. Flux data for usage per user per account is uploaded into mreports nightly, and so the users on the admins list can go to that website and actually view the data. And so then we're going to need a short code to charge it against, and we're going to need a short code authorized signer to make the request. When an account is first created, basically because when it's first created, this list of admins doesn't exist. The person who makes the request needs to be the authorized signer under short code, basically who's allowed to spend the money. At that point, though, when you say, please create this, you can say, and enable my postdoc, my lab manager, whoever you want to also be able to make, changes, which is basically added to this list of admins. From that point forward, when there's the expiration emails or you want to add cores, we will take anybody on this admins list word as golden for spending money on the short code you authorize. Do we know how long the subsidies will remain? Actually, yes, we do, actually. So if we go to the Flux page on the ARC website, prices where it has the pricing for all of this. So here's the standard Flux, Big Mem, FOE, and GPU. And here's the subsidized prices. Notice here, these rates will not increase until July 1st, 2016 at the earliest. So these prices are good through at least 2016. I would encourage you, though, if you think this is a useful thing, to contact your necessary person here for your department to encourage them that these subsidies are necessary and things like that. So if you think this is if you didn't have these subsidies, you couldn't do your work, be sure to add your voice to the discussion so that they know everybody who's benefiting from this. What is the current average wait time for PBSQ in Flux standard? It is 0. Actually, okay, so a little bit of details there. We only start jobs every 90 seconds, and there's certain conditions right now where our software hangs up for an extended period of time, but normally no more than 10 minutes. If you have a Flux allocation and you ask for what we consider something regular, that is some number of cores with 4 gigs of memory or less, we guarantee that your job starts. When you start asking for things that Flux is not, that is, remember Flux standard has 16 and 12 core nodes. If you ask for exactly one node with 16 cores in it, well, only some of the nodes have 16 cores, and sometimes we see jobs blocking, even though there may be thousands of CPUs free. So on standard Flux, and actually on Big Mem Flux, and the goal of all the Flux services are that you should always be able to get exactly what you paid for. So using, here, let me just type out some of the syntax here. So let me, Let me just stick a slide in here. Okay. Okay, so if you do something like prox equals 20, pmem equals 3 gigabytes, so what does this mean? This says give me 20 processors anywhere and 3 gigs of memory per core or more. So this is what we consider a standard thing. It's less than 4 gigs per core. We're not asking for any specific node layouts. This should always start. This, on the other hand, will not always, which is nodes equals 1, ppn equals 16. This asks for a whole 16-core node. 6,000 of the Flux cores are 12-core nodes, and 4,000 are 16-core nodes. Sometimes we don't have 16-core nodes free, but we have literally 100 12-core nodes free. This is the most common thing how jobs don't start right now. So when you start doing these constraints of how you want things laid out, sometimes it takes a little while for the system to have some jobs free up, move them around and such to be able to satisfy a more constraining request. Something else that might not start right away would be something like this. Prox equals 1, but pmem equals 60 gigabytes. Well, you effectively caused the same problem here. You're only asking for one processor, but because you're asking for 60 gigabytes, only the 16-core nodes have 64 gigs of total memory. Remember, we build it with 4 gigs per core. So the 12-core nodes only have 48 gigs. So even though this is a one-core job, it won't start on a 12-core node. It will only start on a 16-core node. And that 16-core node has to be almost empty to have 60 gigs of memory free. So this is the common problem people run into when they say their jobs don't start. In general, though, we guarantee that the resources are there. We only slightly oversubscribe Flux to keep the cost down, and because we know that utilization across all the accounts is relatively low. So like right now, I can show you that Flux actually has normally a few thousand cores free currently. Here, I can go ahead and here, I can switch over to my terminal and I can show you. So if I SSH to Flux login M token, okay, so if I actually run the command free nodes, this will show you how much stuff is free on Flux. Sometimes it takes a little while, but you should actually see that there's a lot of free cores on Flux. But you'll also notice that the number of free nodes is not necessarily the same. That is, it'll show you both by core count and by node count, because you may share a node with another user. So normally there's fewer free nodes as a percentage than there are cores by percentage. And so there may look like there's a lot of cores free, but whole nodes won't be available. So I don't know why people keep asking that question, because honestly, jobs who ask for what we actually provide on Flux have always started in reasonable time, unless we had a software problem. And those normally get resolved pretty quickly, but you can always email us at hpc-support if you think anything's going on, or we're not aware of it, something going on. So actually, let's take a look here. So here's Flux by node, and we're only 71% allocated by node. So that means we have 30% of the nodes free. And then here's Flux by core. And you can see we have 10,000 cores up, and only about 7,000 of them are in use. So that means we have a few thousand cores free. You may also notice that it currently says configured for 12,000. We are currently in the process of adding 2,000 more cores to Flux of 16 core nodes of 64 gig of RAM. So the 16 core per node jobs, hopefully lives will get a lot easier in the future. You also see we have the same information here for Flux M. Currently only 2 of the large memory nodes are in use, but 24 of the cores are in use. Hopefully that answered your question. If you have any concerns about that, let us know. But yeah, the way Flux is built, where it's like you pay for it and it's reserved, it's only slightly oversubscribed, it's supposed to recreate the experience as though you owned machines. You're always supposed to be able to get it when you want it. But at the same time, because we're co-locating everybody together, we're effectively time sharing. So when you're not using it, I'm using it, because we have over 100 unique accounts and projects using the cluster. It averages itself out. So we can drive the cost down for everybody, but at the same time, we can keep it useful to everybody. When Flux on Demand becomes available, because I do expect to become available at some point, that's a different story. That is a case more like a traditional cluster where you have so many hours, you can run whatever you want, but you wait in line. We try to guarantee that you don't wait in line, but you can't run whatever you want. You know, you're in this fixed box of cores. So it's a lot like renting in a node, but instead of renting in a node, you're really renting a core, and that core may be anywhere. Okay. So that's what we need to actually create an allocation. Going back to what we were talking about, we need that start date and duration. We need the number of cores and type of cores. We need who can access it. We need a list of admins for it, and we need basically the account to charge against. Once this is set up the first time, as allocations expire, I get a lot of emails from admins and stuff saying, renew this for 6 more months, same short code. That is fine, and that basically tells us don't change the list of users, don't change the list of admins, use the same short code you had on file for the previous allocation, and don't change the core count, and just extend it out for so many more months. So once this is done the first time, this is pretty easy to go. Now, something I want to demonstrate to you, though, is the fact that you can have multiple allocations in an account. So what I've illustrated here is what an Flux account actually looks like. The account holds the list of users who are allowed to run the jobs. Normally, they're of the name PI name _ Flux. So like an example of this is something like engine Flux. This is an allocation that the engineering school pays for that all engineers can use. It's very small, very similar to LSA Flux. Inside that, though, we actually have multiple what we call allocations, and that's actually where the cores, the start date, the duration, and the funding and the short code go. And so this account, this thing that I can submit jobs against, actually lets me run the sum of all active allocations. So let me illustrate that. Here I just have a basic block diagram because we're working these integer months and integer number of cores, where over time I have this one long-running allocation that's 50 cores for 12 months funded by short code A. But then you can see here that I asked for 100 more cores for 5 months funded by account B. So while both of these are active, the account, the thing I submit to, the thing that has my list of users, is allowed to run up to 150 cores worth of jobs and the corresponding memory that goes with that. So this is where you can have multiple allocations. You can stack them. They can all have their own short code. So you could combine a grant short code and a research incentive short code, right? And say you wanted 20 cores, you could fund 10 with A and 10 with B, or 15 with A and 5 with B, to kind of divide up your money how you wish. The start dates can be whenever. You can ask for allocations to start in the future. If you know that 2 weeks from now you want 50 more cores, you could just tell us day one, hey, make a second allocation that starts on the 31st. And we can do that. Allocations can start whenever. Normally you want them to start at midnight because that gives you the full day, but we can sometimes rush them through and have them start like right now. But you miss out on part of the day because everything synchronizes at midnight. If you had one start now, so you would have lost the time from midnight to 2 p.m. But given it's only $6.60 for an entire month, a couple of hours sometimes isn't that important to you. Sometimes getting running sooner is more important. So you can stack these how you please. The other thing you can do is you can end them early. So say I found a problem, here with my code, and I need to go do some development, and I don't want to be paying for this Flux thing anymore. But I asked for 5 months. Well, what you can do is you can write and say, hey, I want to cancel all my allocations. What we'll do there, because they have to last for full months, at the next month boundary. So if you started it on the 5th, remember it renews on every 5th, we will stop it at the next 5th for each of your allocations. So that way you always get your full month, but we stop it at the earliest month thing. So it is better and easier for you to always have a longer allocation and then cut it short than to ask for a new allocation every month. So that's kind of what goes on. Oh, the other thing you can do is, so when I ask for this 100 core allocation, say I ask for it for some time in the future, this will automatically show up. So here, sometime here before it, I can pre-queue jobs. If I know, if my users come to me as a professor and they're like, we found a problem, we got to rerun everything, by next month for some paper. Can we get more resources? You can tell them, okay, I'll ask for 100 more cores. They can queue their jobs right then, and they just queue up in the queue, right? And they'll fill up the 50 that they already have, and they'll keep running. But you tell us, hey, add 100, have it start at midnight so we get our full time. At midnight, those queue jobs will just automatically flow into that 100. So you can pre-queue jobs. So when you're asking for more cores, have your stuff already in the system, so as soon as they start, things are already running and you get the most out of your resources. So there's another thing here. What happens if okay, so ignore this 12-month thing. Just look at these as boxes. What happens if I do this for renewal? I'm doing this month by month thing instead of, I have a lot of faculty who do this. They just keep renewing. They only do 1 month long because that's the minimum amount of time, and they keep asking for things month to month. There is a problem with this that can bite you. It's a very rare case, but what happens is, in the background, we actually take the area in this box. We're tracking the number of seconds that you're actually using. So this actually means two things. Jobs only have to start when the allocation is active. They don't have to finish by the time the allocation ends. So here's what that means. If I started a really long job right here, it will run past the end of my allocation. It has to start while the allocation is still active, but it will run past the end. Now, why is that? It's because we're taking the area under the curve. If you have 10 cores for a month, you have 10 core months of time that we track. When you queue a job, when it goes to start, the system makes a lien against that 10 CPU months of time. And so if you ask for 10 cores for 2 weeks, there's 20 CPU weeks deducted from that amount. And when the job finishes and it runs for, say, half the amount of time, we return half the amount. So we will let any job start that will consume less time than what the total area under the curve is. So if you don't run anything for a month, and on the last day of your allocation start a very long job, we will start it because there's enough time left in your bucket that you paid for to run. But again, you always have to have it start before the allocation expires. And so you can actually have jobs run over the end of your allocation because you're never using more than your 10 CPU months, right? Because it's the area under the curve. So what this also means is when you do this month-to-month thing is when we extend an allocation, we don't actually extend it. We create a new one that starts at the same time the other one ends. So it looks like this. There's a discontinuity at this boundary because starting a really long-running job here right at the end of the first one, but before the other one starts, if you don't have enough time left in your bucket, it won't start even though you're thinking, hey, I'm supposed to be able to use these cores. It's a very rare case, a very, very rare case, but it is possible to happen. So it is better to ask for one really long allocation than ask to cut it short than it is to keep re-upping every month, because then you don't have this discontinuity between allocations. Hopefully that made sense. So that is really everything we have. So we've covered the Flux services. We covered how to request an allocation. We pointed out how you can stack allocations, have them go into the future, where you can pay for them in different ways, and you can bundle multiple allocations together under one account. Also, any given research group can have multiple accounts. So if you needed multiple of these buckets that have a unique list of users, you can create as many of those as you need. We just go through the process again of who should have access, how many cores do you want. Every account requires one allocation. So who can have access, who's the admin, number of cores, start date, duration, short code. That's how it works. So you can make as many of these as you need to have the functionality you need. Maybe you need to split up 2 different research projects. Maybe you have a very important project that you want to isolate from everything else. You can create a second account to run against with its own allocation to put them together. So that's everything I had. Here's the links to everything. Again, for questions, send them to hpc-support@umich.edu. This is going to be recorded and posted with all of our other video tutorials on our YouTube page, which is the first link there. You can find information normally soonest from us from our Twitter feed, and then you can find lots of details on Flux at the ARC website there at arc.research.umich.edu. If you have any questions, go ahead and put them in the box. Send them to me, or you can email us at hpc-support and I'll get back to you if it's a more involved question. That's really everything I had, though. So thanks a lot for your time. I'll take any questions now. Okay, well, thanks for attending. I'm going to stop the recording.